Today I'm going to solve some problems using mesh analysis. Okay, so let us start with a problem. Okay, I'll just draw the diagram here. So this is the network given. We have a 5-volt supply here. There is a resistor connected here. So this is another resistor. Okay, then we have resistor connected here. Then there is a 10-volt source. So I'm just marking 10 volt. We have 1 ohm. Then we have 5 volt, then 2 ohm, then 3 ohm and 4 ohm resistor. The question is to find the current through 3 ohm resistor by mesh analysis. So how will you do this? So before starting on to going to solve the problems, what we have to do is we have to assume the current direction in the mesh. So first you have to identify how many mesh are present in this circuit. Okay, so I'm just we can see that there are 2 meshes present. Mesh means a closed path. The basic elementary form of a loop is called a mesh. So here you have 2 mesh. So I'm just assuming the currents I1 and I2 in these 2 meshes. Okay, now I'm going to write the equations. So first we will apply KVL to mesh 1. So what is KVL? KVL is Kirchhoff's voltage law, which states that the sum of voltages in a closed loop is equal to 0. Okay. So when you are considering mesh 1, sum of voltages in this particular mesh should be equal to 0 when you apply the Kirchhoff's voltage law. So let us take this loop. 10 volts. So current is like it is marked in the clockwise direction. So we know it is like when you are marking the current, the conventional direction of current is from positive to negative. So here it is plus to minus, here it is plus to minus. You can just mark the directions. Now just write the equation. So first we are going from moving in the clockwise direction. So 10 volt, then minus the drop across this one. 1 ohm resistor is minus, that is resistor into current. So 1 into I1. Then comes to here the 3 ohm resistor. When you are seeing this 3 ohm, there are 2 currents passing through this 3 ohm. One is I1, one is I2. You can just see I1 is in clockwise direction and I2 is also in clockwise direction. Okay. When you see this one, when it is passed on this one, okay, I'll just show the thing. Now the current here it is, you see it is moving. I1 is from left to right and I2 is from, you can see it is moving like this from right to left. So I1 and I2, when it is passing through this 3 ohm resistor, you can see that it is in the opposite direction. So you should take it as the difference. Sorry, I just, so we're just writing minus 3 into I1 minus I2, then minus, then which resistor is remaining in this mesh? 4. So what is the current flowing through this 4 ohm is I1. So it will be the voltage drop across the resistor 4 ohm will be 4I1, that is equal to 0. Now when you simplify this equation, you will be getting the equation as 8I1 minus 3I2 is equal to 10. So this is our equation number 1. Now what we do? Now consider the mesh 2. So when you consider the mesh 2, we can apply KVL to mesh 2. KVL to mesh 2. When you apply KVL to mesh 2, just see 5 volt. Okay, 5 volt, you know it is from negative to positive means it's a voltage, right? So we will be giving a positive sign. Then the current is in clockwise we have taken. So this drop across this resistor, you can see it is plus minus. Here it is plus minus. Okay. So now when you write the drop across the 2 ohm, it is minus 2 into I2 and minus 3 into, but the current through 3 ohm resistor is the difference between I2 and I1. So it is I2 minus I1, that is equal to 0. So when you simplify this equation, you will be getting minus 3I1 plus 5I2 is equal to 5. So this is our equation 2. Now you got two simultaneous equations and two unknown. So when you solve these two equations, you can find the values for I1 and I2. So solving 1 and 2, equation 1 and 2, we will be getting I1 is equal to 2.097 amperes and I2 is equal to 2.26 amperes. What is asked in the question? See, find the current through 3 ohm resistor by mesh analysis. So you are supposed to find the current through 3 ohm resistor. So what is the current through 3 ohm resistor? It is I2 minus I1. So current through 3 ohm, let me write it as 3 ohm, that is equal to I2 minus I1. We already know the values for I2 and I1, substitute it. So you'll be getting the value as 0.163 amperes. Okay. So this is the solution for that problem. Okay. So we'll solve another problem. One more problem we'll solve here. I'll just draw the network. So here we have a 3 ohm resistor here. We have a voltage source 4 volt, 4 volt. Then we have 2 ohm here. We have 1 ohm, then 4 ohm, then we have 6 ohm, and this resistor is 5. Okay. Now consider the question is find the value of current supplied by the battery. Supplied by the battery. So how will you find this? So using mesh analysis. So here when you observe this network, you can find that there are it consists of, the circuit consists of 3 meshes. Okay, so you have to assume current for each mesh separately. So let me assume this current as I1, this current as I2, and this current as I3. Okay, now we will write the equations for each mesh separately. So now let us apply KVL to mesh 1. You apply KVL to mesh 1. This 4 volt, starting from 4 volt, 4, and the drop across this 3 ohm, you know, it is the current is from positive to negative. So it will be like this. So 4 minus 3 into I1. Then in this mesh you have 2 more resistors, that is 1 ohm and 4 ohm. Here if you see this path, so what is this the voltage drop across this 1 ohm? What is the current through this 1 ohm? We can see that current I1 and I2 is flowing through 1 ohm. So it is in opposite direction. So we'll be getting minus 1 into I1 minus I2 as the drop across 1 ohm resistor. Then we have 4 ohm resistor. So the current flowing through 4 ohm resistor, I1 and I3 is flowing through. So just check the direction, it is in opposite direction. So we have to take the difference of those two currents. So I1 minus I3, that is equal to 0. So this is our first equation when we apply KVL to the mesh 1. So when you simplify this equation, you will be getting it as 8I1 minus I2 minus 4I3 is equal to 4. This is our equation number 1. Now apply KVL to mesh 2. KVL to mesh 2. When you apply KVL to mesh 2, what will be getting? No, mesh 2 consists of 1 ohm, 2 ohm and 5 ohm resistor. See, 1 ohm when you are considering, the current flowing through, it is I2, both I2 and I1 is flowing through 1 ohm resistor, but it is the difference of the current. So now we can write minus 1 into I2 minus I1, then minus 2 into I2, then minus 5 into I2 minus I3 is equal to 0. This is the equation for mesh 2. So when you simplify this, you will be getting minus I1 plus 8 I2 minus 5 I3 is equal to 0. This is the equation 2. Okay, I'll now apply see, for just checking the diagram, I'm just writing here. Okay, I'll just write it here. So I'll KVL to mesh 3. So when you apply KVL to mesh 3, we know mesh 3 consists of 3 resistors, that is 5 ohm, 6 ohm and 4 ohm. So we can write minus 6 into I3, then minus 4 into, okay, this two currents are there, I3 minus I1, then you have minus 5 into I3 minus I2, that is equal to 0. So you got that equation. Now simplifying this equation, we'll be getting minus 4I1 minus 5I2 plus 15I3 is equal to 0. This is equation number 3. So we got 3 equations corresponding to these 3 meshes. Okay, and we have 3 unknown quantities, that is I1, I2 and I3, and we have 3 equations. So 3 equations and 3 unknown quantities. So we can solve this simultaneous equations to find I1, I2 and I3. So you solve these 3 equations, you will be getting I1 as 0.66 amperes, I2 is equal to 0.24 amperes and I3 is equal to 0.26 amperes. Okay. Now what is asked in the question? Find the value of current supplied by the battery. So you can just see battery is here 4 volts. So which is the current supplied by this battery? We can see that it is I1. So current supplied by battery is nothing but current supplied by battery is I1, that is equal to 0.66 amperes. Okay, so this is the answer for that one. We will solve one more problem for this mesh analysis. Okay. So 10 ohm, here it is a 25 volts, then here it is 15 ohms, then here you have 15 volts. Okay, then you have a 5 ampere supply. So the question is find the value of current flowing through 10 ohm resistor in the circuit. Okay, so we are supposed to find the current flowing through 10 ohm resistor. Okay, now here in this diagram you can see that two meshes are there, so assume the current in those meshes. Okay, I'm just doing I1 and I2. Okay, just assume two currents I1 and I2 in those two meshes. Now we will apply KVL to mesh 1. So when you apply KVL to mesh 1, what are the elements present in mesh 1? We have a 10 ohm resistor, then we have a 25 volt supply, then we have 15 volt supply and 15 ohm resistor. Okay, so in 10 ohm resistor current I1 is flowing, and in 15 ohm resistor we can see that both I1 and I2 is flowing through 15 ohm. Okay, so we are writing the equation, the minus 10 into I1, that is the top across the 10 ohm resistor. You can see for this 25 volt, when you are traveling in the clockwise direction, you can see 25 volt, it is from positive polarity to the negative polarity. So there is a drop in potential. So you have to give a negative sign. So minus 25. Then 15 volt, when you are moving like this in the clockwise, you can see that first we are reaching the negative polarity and then going to the positive polarity. So there is a rise in potential. So you should give a positive sign. So it should be plus 15 volt. Okay. Then what is the drop across 15 ohm? So when you consider this 15 ohm resistor, the polarity, okay, here it is plus, here it is minus, this is plus, this is minus, okay, depending upon the current direction. So this 15 ohm, we can see that current I1 is flowing from right hand side to left hand side, and this I2 is from left to right. So both are in opposite direction. So you need to subtract those currents. So it is minus 15 into I1 minus I2, that is equal to 0. So when you simplify this equation, you will be getting it as 25 I1 minus 15 I2 is equal to minus 10. Oh, this is the equation 1. Now see mesh 2. Mesh 2, when you want to apply KVL, you can just, there is a difficulty there because there is a 5 ampere current source present there. Okay. So what we can do is we will be writing the separate equation for this current source. Okay. So what is the current flowing in this mesh? It is I2. Okay. And here it is directly given it as the 5 ampere. So we have taken I2 in opposite direction to this 5 ampere. So I2 we can write it as minus 5 ampere since it is opposite direction. Okay. So we have got the second equation, that is I2 is equal to minus 5 ampere. It is directly given in the question. And since we have taken I2 in clockwise direction, that is just opposite to the current direction, current source direction. So we have to put a negative sign there. Now we have, see, we have two equations and one unknown quantity here. So you can easily find this I1, substitute this value of 5 ampere here. You can find the value for I1. So I1 is equal to, when you substitute, you will be getting the value as 3.4 amperes. So what is asked in the question? Find the value of current flowing through 10 ohm resistor. So we want to find the value of current flowing through 10 ohm resistor. So we can see that as the assumed direction, as the assumed current, I1 is flowing through 10 ohm. So current through 10 ohm is nothing but it is I1. So that is minus 3.4 amperes. Okay. Why it is minus negative sign is coming? Because the assumed direction, whatever the direction we have assumed, is opposite to the actual direction. So the answer will be correct. Only thing is, if the assumed direction is wrong, then we will be getting a negative answer. That's it. Okay. So I suppose you understood the thing. Okay. Now we will solve more problems later.